will discuss sulfuric acid. So sulfuric acid H2SO4. Okay, and here this one, it is used to manufacture almost all these compounds, all the chemicals. That is why this is known as king of chemicals. This is known as king of chemicals. And this concentrated the sulfuric acid, it is very thick. So due to its viscous, as it is viscous liquid, it is known as oil of vitriol. Okay, here it has two number of hydrogen, so it is dibasic acid. It is dibasic acid. Here this sulfuric acid, here we can say it is a mineral acid. It is a mineral oxyacid. It is a mineral oxyacid. Why it is oxyacid? Oxygen is present. And here this one, it is produced due to the oxidation of nonmetal, addition of water, all these things. Okay, so this is about sulfuric acid. It is king of chemicals. It is oil of vitriol. Then something about this general preparation we will see. And for its occurrence, free state it occurs, but it is very low percentage occurrence. And here we can say this one, it is for this springs, all this it can be found very less percentage, but in the combined state it will be found in the form of the sulfates. So sulfate, any sulfate form, it will be in the combined state. It will be in the combined state. Okay, now we will go for some general method of preparation. 2-3 general method of preparation we will take. So here we know when non-metals like sulfur with oxidation, it gives rise to sulfur dioxide. This sulfur dioxide with further oxidation and addition of water to it give rise to H2SO4. H2SO4. Okay, so this one will be the first method of preparation. What will be the second method of preparation? Second method of preparation is oxidation of sulfur by concentrated HNO3. By concentrated HNO3. So what happens here? Here if we will take sulfur plus HNO3, this HNO3 must be concentrated. It gives rise to H2SO4. Along with that one nitrogen dioxide, along that one will be water. So let us balance this one. This one will be 6. This one will be 6. So 18. This one is 12. Okay, 14. This one will be 16. Okay, so these two general method of preparation we will take. More are there, but let us take these two. Then we will see this this is the general method of preparation. Now we will see that what is the large scale of preparation of this sulfuric acid. So large scale also it is known as industrial method. So large scale preparation, otherwise it is known as also industrial preparation. Industrial preparation of H2SO4. Okay, so what are the different stages for it? What are the different steps for it? Let us consider. After that one, we will discuss everything. So here, this large scale preparation, this can be done in 5 steps or 5 stages. So first one, what will be the stage? First stage will be production of SO2. This production of SO2. This SO2 can be done by 2 ways. Here, this one can be done, sulfur burning in oxygen can give rise to sulfur dioxide. Otherwise, we can take iron pyrite and here burning with oxygen give rise to Fe2O3 along with that one sulfur dioxide. This can be also, these are the two ways which one can be preferred, that one can be taken. So production of SO2. So here if we are taking this SO2, getting SO2, this SO2 must be purified. So this one, second one will be purification of purification of SO2. So there are different stages for purification. We will discuss it afterwards. Third step will be catalytic oxidation. So here catalytic oxidation of SO2 converted to SO3. Okay. Fourth one will be absorption of SO3 in concentrated H2SO4. Here what is that one? Here converted to oleum. We are converting that one to oleum. We will see why this one SO3 is not directly, but when we saw the equation, there we directly added SO3 with water, but here we are not taking, rather we are taking this one concentrated H2SO4 to get the product oleum. So what will be the fifth step? Fifth step will be the dilution tank. This one will be dilution tank. This one will be dilution tank. So what happens in this dilution tank? Here oleum, it is converted to H2SO4 according to the, here dilution will be, the dilution means water will be added to oleum, so that we will get H2SO4, and this H2SO4 whatever we will get, that one will be according to our desired concentration. Okay, so these are the 5 steps how we are getting it. So if we will take this one in the form of the flow chart, and yes, one thing it is, the name of the process is contact process. This name of the process is contact process. In case of ammonia, that one will be Haber's process. In case of HCl, that one will be inverted funnel arrangement. In case of HNO3, nitric acid, that one it is Austral process, and in case of sulfuric acid, that is your contact process. So here let me write again here this one, ammonia, Haber's process, because this is the board question. Haber's process, one table was given, and in this table name was given, reactant, but I will show you that one. Here HCl, that one will be inverted funnel arrangement, funnel arrangement. Here HNO3, this one will be Ostwald's process. Fourth one, this one will be H2SO4. This is your contact process. This is contact process. Okay, so remember this one. Sometimes this one it is a board question only. Here one question was given, just like a table it was given, and in this table all these 4 was there. Some case it was the product given, some cases reactant, okay, some cases catalyst. This one will be, one thing it will be, if it will be given ammonia, product it is ammonia, name the process, name of the process. Okay, you have to write it Haber's process. Here if it will be given, name will be your this Austral process, what will be the product will be asked. If it is given H2SO4, what is the catalyst it is used. So all these are the board questions, you have to remember this one. Okay, so in this contact process, what we are going to just, I will show you that flow chart so that you can remember. Here first of all we are taking production of SO2. SO2 is produced, 2 ways are there. Here another way, by anything it can be. So this one will be purification. This one will be purification of SO2. Okay, after that one, what we will get? Catalytic catalytic oxidation of SO2 means it is converted to SO3. What it is next? Next it is your absorption tower. Absorption tower. Here in this absorption tower, SO3 it is converted to oleum. Here this one will be dilution tank. This one will be dilution tank, and where we are getting desired amount, desired concentration of H2SO4. Okay, so this much. Now we will go for the process. Now let us see what should be the condition for maximum yield of sulfur trioxide. So the best conditions on the basis of Legge-Adres principle. So it should be of high pressure. High pressure means what should be the pressure? Nearly 2 atm pressure. Okay, so it should be at high pressure. And here another one should be at low temperature. It should be at low temperature. Here low temperature means to maximum yield of SO3, conversion SO2 to SO3, here nearly 450 degrees Celsius we are taking. And here it is this reaction, it is highly exothermic reaction. So first of all, this temperature is given. After when reaction already started, after that one, this outside heating, it will be stopped. So whatever heat evolved in this reaction, that one will proceed of this reaction will forward. Next one will be, what is that? High concentration of air must pass. Air means here I mean to say it is oxygen. What is that? First of all, sulfur converting to sulfur dioxide, otherwise iron pyrite converting to sulfur dioxide, there oxygen needed. Here SO2 will convert to SO3, there also oxygen needed. That is why high concentration of oxygen is required. Next one, this catalyst. What should be the catalyst? Here two type of catalyst can be used. What is that one? One can be vanadium pentoxide, another can be platinized asbestos. Okay, so here this platinized asbestos are not used. These platinized asbestos are not used because whatever these impurities are present, it poison the catalyst, and this one also it is costly. Time to time may replace, that is why we are not using platinum. Rather vanadium pentoxide, it is cheap and it is very not poisoned by the impurities. Here it is not poisoned by impurities. Okay, this one will be poisoned by impurities, that is why it is not used. Then here these gases whatever we are using must be pure gases. The gases must be pure, otherwise it will poison the catalyst, decrease the efficiency of production of SO3, decreases the production or efficiency of SO3. So these are the conditions for this maximum yield of sulfur trioxide. Now let us see this preparation, large scale preparation or industrial preparation. So many boxes we have taken, so many chambers we have taken, towers we have taken. Let us see. So first one it is, this one is the production of SO2. Here production of SO2, it can be, this is the first step I am writing here. So first step, I told first step it is production of SO2. In this case, this sulfur burns with oxygen, give rise to sulfur dioxide. This may be sulfur dioxide it comes. Otherwise, it can be your FeS2 iron pyrite burning with oxidation. Here we are getting Fe2O3 along with sulfur dioxide. Here this is the roasting process which we have read in metallurgy chapter. So this one will be the process. here this one will be, let us balance 11 oxygen, 2 Fe2O3 and 8 SO2. So this is the first step. Now we are getting sulfur dioxide. Maybe these two ways, any way it is preferred, that one can be taken. Along with that one, we can take oxygen, because continuous supply of oxygen must be required, because here in when we are will have this oxidation process here up to here, that time it is required. So along with sulfur dioxide, here production of sulfur dioxide, this one will be the first step. Then what I told that one will be, second one will be purification of sulfur dioxide. Whatever sulfur dioxide we are getting, that is not 100% pure. That is why we need to purify it. So there are different stages, you see. First one will be your dusting chamber. Here sulfur dioxide goes through the dusting tower. Steams, downward flow of the steam will be there. So when there will be downward flow of steam, these dust particles, they settle down. They absorb, this dust particle absorb moisture and they settle down. Now this hot SO2, because here it is burning, here it is steam, obviously temperature will be more, and this SO2 along with this oxygen, it will move. Here it is your cooling pipes. The purpose of cooling pipe is to cooling the gases passing through the, here it is cooling pipe. The purpose of cooling pipe is to cool the gases whatever it comes. So this gas again goes to the scrubbing tower. In this scrubbing tower, what happens? Water will be sprinkled. Here it is steam, but here it is water. Whatever remaining the dust particle will be there, they will be absorbed, they will be settled, and gases will go to the drying tower. Why this one was needed to have the drying tower? Because spraying water. So gases have some water molecules, moisture, that is why they need to absorb this dry. So here what is the process what we can take to dry it? Here the best drying agent required for drying this SO2 is concentrated sulfuric acid. This concentrated sulfuric acid will be sprayed downward direction, and these gases will be, as the gases they will move and they will go to the arsenic purifier. This one, it is very important. This arsenic purifier, it is the chamber where there is, see that one, like the steps only we have kept for this arsenic purifier. FeOH whole thrice. Here we have taken FeOH whole thrice, means this one will be ferric hydroxide, it is taken. Here this one is ferric hydroxide. Here it is ferric hydroxide, it is used. So when this one, it is so sulfur dioxide goes, whatever these arsenic oxides are there, they will be they will be absorbed by this ferric hydroxide. Okay, so next is that one we are going for the testing box. So here this testing box, role of testing box is important. Here what we are passing, this one it is, we have to pass the light. You must have seen, if all the doors, windows are closed in a room and there is a, so obviously it will be a dark and there will be a small hole in the window. So light used to pass through that window, and we see that some of the particles, dust particles, they just float on this sorry they just float on this ray in which the ray of light goes. And if there will be, we will find any sort of dust particle that is floating in the ray of light, then it seems that this sulfur dioxide, it is not purified. Again it has to come to the, again the same process from testing tower, again all this they have to pass through all these purification chambers. Then after that, this sulfur dioxide gas along with oxygen has to pass through the contact tower. So here in the contact tower, as we have discussed already, we have taken V2O5 vanadium pentoxide. It is the vanadium pentoxide we have taken, and in this case this is contact tower. Okay, now let us see. Here we have discussed part 2 will be this, from here to here will be your purification. So this one will be 1, this one will be 2 purification chamber. After that one, third part we will discuss, that one will be stage 3 or step 3. In this step 3 what happens, this one will be the contact tower where we have getting this. So here what happens, sulfur dioxide along with oxygen in the presence of vanadium pentoxide. Here this one will be the reversible process. Here we are getting SO3 along with some amount of heat. It is exothermic reaction, and here we have taken temperature is 450 degrees Celsius, and here pressure is 1 to 2 atmospheric pressure. Okay, so in this condition, and we have discussed also vanadium pentoxide, it is cheap and it is not easily poisoned by these impurities. That is why it has taken. So and here this oxygen should be continuously supplied to it. Maximum amount of oxygen should be there for this high yield of sulfur trioxide. This one is over here, pentoxide outside. First of all, it is heated from outside. That is why it is catalytically, electrically catalytically heated this tower. Otherwise, it is oxidation tower also, because oxidation takes place and it is converted. SO2 come in. This is contact tower. So SO2 come in contact with oxygen in presence of vanadium pentoxide at 450 degrees Celsius, 1 to 2 atmospheric pressure, and SO3 gas is produced. Now we will go for this one will be SO3 gas. SO3 gas comes. This SO3 gas can be converted to sulfuric acid by addition of water. Okay, but here what happens, this we are not using that one. This one will be step 4 for us. Rather, what we are taking, this sulfur trioxide with concentrated H2SO4 taken. It is in the dilution tank, or this one it is the absorption tower, SO3, and here what we are getting, H2H2O7. This name is known as oleum. Here it is otherwise, the other name is pyrosulfuric acid. This other name also pyrosulfuric acid. From SO3 we are getting this one. Here next one is fourth step is, this one is fourth step. Fifth step is dilution. What happens in case of dilution? This oleum H2H2O7, here it is diluted with water to give desired amount of H2SO4. Okay, so here whatever, because depending upon this amount of water you are adding, this SO2, this sulfuric acid can be of that concentration. Now question arises, why we are not using this directly SO3 to water? Here when SO3 is added to water, remember this one and listen it carefully. There will be some fumes of and the mist of sulfuric acid will be formed, okay, which is difficult to condense. That is why SO3 is not directly absorbed here. Okay, so let me rub this one and let me write this again. Okay, so why SO3 is not added, everything I will write. So let me rub this one. Now question arises, this sulfur trioxide, it is acid anhydride of sulfuric acid, because SO3 plus water give rise to H2SO4. But SO3 is not directly absorbed in water to give H2SO4. The reason is that here when it is highly exothermic, this reaction is highly exothermic reaction. Highly exothermic reaction. Second, here it will be what happens, a dense fog of sulfuric acid particle is formed which is not condense easily, which do not condense easily. Okay. Next is that here along with this sulfuric acid, here it can be this H2SO4 fog. The fog of H2SO4 contains sulfuric acid particles of sulfuric acid, then unreacted SO3, unreacted water vapors. So here this H2SO4 is not, the purpose will not be fulfilled. So here sulfuric acid fogs, they consist of sulfuric acid particles. Along with that one, when it is made steam, here it will be unreacted sulfur trioxide particle will be there along with water. Now, so here this whatever the mist it is produced, they prevent dissolving in water. Now next one is this sulfur trioxide. This sulfur trioxide does not dissolve. The sulfur trioxide does not dissolve in water sufficiently or satisfactorily. It satisfactorily. Okay. So it produces lot of amount of heat and forms this mist droplets of H2SO4, difficult to condense. That is why this process is not used. And another one is when we are taking this vanadium pentoxide along with this vanadium pentoxide, some promoter can be also used in this case to proceed the forward reaction along with vanadium pentoxide. Here some percentage of K2O also can be taken here. Here potassium oxide also can be used so that this forward reaction can be possible. Okay, so this is all about the preparation of sulfuric acid by this contact process.